Hello my dear students, again very welcome to all of you in your physics class, and today we will talk about some theorem to find the moment of inertia about different axes. Okay. These theorems are called axis theorem, perpendicular axis theorem, parallel axis theorem, very interesting. What actually the application of these theorems? Okay. Whenever you want to change the axis of rotation, okay, we can use this theorem. Okay. Like the moment of inertia of any body will depend on the axis of rotation. About which axis of rotation you are finding the moment of inertia is very important. Okay. If you are finding the moment of inertia of a ring about the axis passing through its center and perpendicular to its plane, the moment of inertia is different. Okay. It is mr square, but what the moment of inertia when you are finding about axis which is along the diameter. Okay. So, we can use perpendicular axis theorem. Perpendicular axis theorem. So, one point always we have to remember regarding this perpendicular axis theorem is that this theorem is applicable only for the plane lamina. Okay? Only for the plane lamina. So, what is meaning of plane lamina? Object which is distributed over the plane, when mass is distributed over the plane like ring, like disc, like rectangular lamina, like square lamina, like triangular lamina. Okay. So, the perpendicular axis theorem you can apply only for the plane lamina. So, let us consider it is x axis, y axis and z axis. Okay, it is x axis, y axis and z axis, and a plane lamina is placed on this, sorry, it is x axis, this is y axis, and let us consider it is z axis. So, this plane axis, plane lamina is placed over the xy plane. Okay. Now, Iz, moment of inertia about z axis is equal to moment of inertia about x axis plus moment of inertia about y axis. It is the concept. It is called perpendicular axis theorem. It is called perpendicular axis theorem. The summation of moment of inertia about x and about y is equal to moment of inertia about z. But in this case you have to remember is that when object is placed in xy plane, when plane lamina placed in xy plane, then only you can say Iz is equal to Ix plus Iy. So, to verify this theorem, Iz is equal to Ix plus Iy when plane is placed in xy plane. When our lamina is placed, plane lamina is placed in xy plane, then moment of inertia about z axis is equal to the summation of moment of inertia about x axis and y axis. So, what we can do? We can consider a small differential part having mass mi, which is at xi distance from the y axis and yi distance from the x axis. Okay. From top view it is x axis and it is y axis. Okay. And it is our lamina, it is our differential mass mi. So, the distance from the x axis is yi and different distance from the y axis is xi. You know very well the coordinate of any point. Okay. X is the distance from y axis and y is the distance from x axis. Okay. It is the top view, when we are observing this plane from the top. So, always y the distance from the x axis and x is the distance from the y axis. So, what is the moment of inertia about x axis? It is equal to summation I equal to 1 to n mi. Oh, and what is the distance of this mi from the x axis? Yi. So, yi square. Okay. and what Iy, moment of inertia about y axis, it is the summation from I equal to 1 to n, we are considering n particles. Okay. So, summation from I equal to 1 to n mi xi square. But if we are finding the distance from z axis, this distance from the z axis, it is the z axis which is perpendicular to this plane now, okay, in this top view. So, this zi can written as zi square according to Pythagoras theorem. What we can write? Zi square is equal to xi square plus y square. So, if we are adding these two, xy plus ix plus iy, we can write summation I equal to 1 to n mi xi square plus yi square. Okay. This summation and mi can taken as common. So, mi xi square plus yi square and this xi square plus yi square, and what we can put? We can put as zi square. So, it will become xi plus ix plus iy is equal to summation I equal to 1 to n mi zi square, and it will be iz. It will be iz. So, it is the verification iz is equal to ix plus iy. Okay. Is this clear to all of you? Now, how we can use this theorem, this perpendicular axis theorem. So, next we are talking about the application of this perpendicular theorem. So, now we are talking about the application of perpendicular axis theorem. So, first application is moment of inertia of ring about its any diameter, So, let us consider a ring which is placed on this x y plane, and this iz, you know very well what is the moment of inertia about the axis which is passing through the center and perpendicular to the plane of the ring is mr square. Okay. And this x axis and this y axis is kind of diameter of this ring. So, if you are finding the moment of inertia about x axis, it should be the moment of inertia about y axis, which can written as moment of inertia about the diameter. Okay. Both are diameter and both will have same moment of inertia. Okay. So, if we are applying perpendicular axis theorem, iz is equal to ix plus iy. I am putting value of ix which is mr square, value of iz is equal to mr square, ix is equal to I about diameter plus iy also I about diameter. So, this is I about diameter 2 times is equal to mr square. So, moment of inertia about any diameter of ring is equal to mr square by 2. Very easily we can find. Okay. If our ring is rotating about the diameter, ring is rotating about diameter, like this is a ring and this is diameter, and this ring is rotating about the diameter, then the moment of inertia is mr square by 2. Same concept we can use for the disc. Okay. What will be the moment of inertia of a disc about its diameter? Okay. So, what you have to do? You have to use mr square by 2 at the place of iz, and it will become mr square by 4. Okay. Let us see how. Now, next application, the moment of inertia of circular disc about the diameter. Okay. So, again we are considering a disc which is placed on this x y plane, so that this z axis is the axis of this disc. So, in this case iz is equal to mr square by 2. The moment of inertia of circular disc about axis passing to the center and perpendicular to its plane is mr square by 2. Again we can say this Ix should be equal to Iy and it is equal to moment of inertia about diameter. This x axis and y axis is kind of diameter of this disc. So, the moment of inertia about any diameter will be same. So, Ix is equal to Iy is equal to I dia. Now, according to perpendicular axis theorem, this Iz is equal to Ix plus Iy and this Iz is equal to mr square by 2 and it can be written as 2 times of moment of inertia about the diameter. So, moment of inertia about the diameter is equal to now mr square by 4. So, if disc is rotating about the diameter, what is the moment of inertia? It is the mr square by 2. These concepts are very important and these are the application of perpendicular axis theorem. Thank you very much.